All right. Hey, everyone. I am Alan Golbig. I am a consulting engineer here at Jamf. Part of my job is to maintain the Jamf Protect GitHub repo, where you can find this workflow that we're going to go over in a little bit.
I'm Stuart Aschenbrenner. I work at Huntress as a macOS researcher. I'm one of the core developers on this Aftermath project.
And I'm Matt Benyo. I am a macOS security researcher that works as part of Jamf Threat Labs, and Stuart was actually formerly part of that team, if you're wondering how he was kind of connected. So we're going to take you through it, give you a quick overview of what we're here to talk about. We're here to talk about Aftermath, which is an open source incident response tool that we built in Swift. So we're going to start, I'm just going to give you the background on where this thing started, what the idea was, and the problems that we were trying to solve with it. So we'll get into kind of the design logic behind it. Then Stuart's going to take us through an overview of how it works, what it does, and after he gives that overview, we're going to kick it over to Alan, who will talk about how we can take Aftermath and integrate it with some more familiar tools like Jamf Protect and Jamf Pro. And then Stuart's going to swoop in and give us an overview of how we can take the data that it sends back to us and analyze it. And then finally, Alan is going to bring it home and give us updates and additions on the things that have been added to Aftermath since it was released roughly 1 year ago. Hey, Stacy. Okay, so to start, let's start at the very beginning. We've got the Jamf Threat Labs. Our job is we're making these detections, looking for suspicious activity on macOS computers. And something that was a recurring thing that would happen is, we're deep in our mind palace and suddenly get this Slack message. Oh, and I totally blew right past it. Hold on, let me go back. Can't go back, doesn't matter. The Slack message was essentially, hey, someone got this crazy alert on their computer and now they're all worried about it and they don't know what to do. Can you help out? And so we would say, okay, well, do you have the data? And they'd say, let me go ask the customer for the data. And then there was this back and forth that was excruciating to everyone, especially the support person in the middle. And one of the main problems with this was that by the time we got involved, by the time we got the data, sometimes it's like 2 weeks had already passed. And can we really effectively talk about the fidelity of the system? Really, we're just focused on the detections. So this was tough. And so we went looking to see, is there a way to actually collect more data so that we could do a more comprehensive investigation? So we went online, and this is a simulated Google search, but you'll find that if you look for this sort of thing, there's not a ton out there. There are a few projects that are decent, but a lot of them are written in Python. Now Python's not natively installed on Mac, so we were like, let's just do our own thing. So we wanted to build something with Swift so that we could leverage a lot of the native capabilities that are part of the operating system. So ideally, you'd have this thing that was just gathering every piece of data in God mode for you so that you'd never lose anything, but that's not practical. You're going to eventually run out of space. So we wanted something that was already installed on the device, so it would be there, ready to go, on standby, for on-demand running that we could automatically trigger to gather every key piece of data and artifact that we wanted when a detection would fire. So what we're able to do then is take a deep snapshot of everything that's going on the system at the moment this thing happens, and then use that for an investigation. And that's the idea behind Aftermath. It's a Swift-based, open-sourced incident response framework that captures all of the essential artifacts that you need to do an investigation, or at least the ones that we think are the most necessary, and then gives you tools to analyze the data to identify what the threat vector was and how to clean it up.
So there's two primary components of Aftermath. We have collection and analysis when we talk about the how Aftermath works. So collection is designed to really query the endpoint, get a ton of relevant raw data that can be valuable in a proper investigation. However, once we have all that raw data, we have to do something with it, make it so it's more human readable, so that's where analysis comes into play. Basically aggregate all this data into one easy to read, easy to view document. So let's start with collection. What is it that we're collecting? What's valuable? So a few of the things we're collecting, we're not going to go through everything, but browser information, right? Browser history, browser downloads. Did they visit a malicious site and download something? As well as did a malicious extension get installed? We also do persistence, not just limited to launch items like launch agents and launch daemons, but to system extensions or periodic scripts or even cron jobs. We collect a copy of the TCC database, all the ones on the system. So there's one per user and one at the root level. This is when software requests access to look at something on your desktop or screen sharing in Zoom or something like that. So we can collect which clients have requested which services and then what action the user took in response to that prompt, the allow or don't allow. Also your shell history, bash, and ZSH, as well as network information, your preferences, as well as current connections. Is anything currently connecting? And of course, unified logs. We have a pile of default logs like login, failed sudo, manually installed configuration profiles, screen sharing requests, and more. You can now do some external logs as well of your choosing, and Alan will get into that later, as well as just some other things, whether it's dumping Slack information, kind of looking through common directories that might have malware in it to see what's in there, as well as process information. However, one of the most useful pieces of collection methods that we do is this the series of methods that we've dubbed system recon. And it really goes through your system and looks for things that is easy to view in just a single document. This is things like your software versions, Xprotect and Xprotect Remediator versions, are they up to date? Your installed apps, the installed history on your device, as well as environment variables and your firewall or screen sharing preferences. So to look at it in action, we can just run it from the command line in this case, use the pretty flag to make the output colorized here. And also depending on how large your system is and how much data is on it, it's going to depend on how long this takes. It can be anywhere from a handful of seconds to a handful of minutes. So what does this produce here? We can dump this information to any directory of our choosing, and it defaults to temp directory, which is where this is. But we have a collection of folders here, titled persistence, artifacts, your browser information, and again, this is raw data. And you can go into these and actually get more granular if you choose to do so. But that's what we did the analysis part for, which is the second part. So once we have our collection of data, typically this would be done on something other than the endpoint, like a security analyst's machine or an administrator's. You just point the Aftermath binary to your collection archive. It'll unzip it for you and really kind of collate, aggregate all this information into a collection of documents that you can look at. So this is the output. These are the documents it creates. There's not more than this. This is it here. So let's just kind of walk through these quickly and talk about what they are. So first up on that top left is just our log file of what we saw in the terminal. Oftentimes, if you're deploying this as an administrator through Pro, you might not be able to actively see that terminal output. So that's where this comes in handy here. We have a file timeline. We walk some of the common directories and actually look for the timestamps on when files were created, when they were last accessed, when they were last modified. And so we can kind of see if maybe malware has created new files accessing certain parts of the operating system. Next up, we also look at a lot of the system logs, syslog, install log, and put it into a document. Again, all this information by itself is kind of tough to look at. So that's where kind of our last file will come into play that we'll touch on here in a second. There we go. We also have a system information. This is that system recon that I spoke about. Just a kind of a dump of common information that you might want to just take a quick peek at and get some more information about that specific endpoint. We're going to skip over that ls quarantine file because it returned nothing in this case for this run. We also collect, as I said, the TCC database. So we really look at these four main, I guess 5 main columns here. Be the client that did the requesting. Let's take Zoom, for example. It requested screen sharing ability, and the user said yes, and it was by the user at this timestamp. And more recently, the XProtect database. Now, this is a database that's from XProtect Remediator, an experimental group of behavioral-based detections that Apple is stepping into. That's those bastion rules in that second column is what Apple is referring to them as. We collect that as well. And then at the very end, kind of the finale, as it were, is the storyline in that bottom left corner. So this takes pretty much all that information and dumps it into one file. So we can actually look at the timestamps of everything. We sort it chronologically, and we can see processes running, if something requested TCC access, files, and things like that. So fortunately, Aftermath doesn't just have to run from the command line, and that is where it can be part of your workflow, and Jamf Pro and Protect come into play.
So let's talk about how Aftermath fits in with tools like Jamf Protect. To illustrate this, let's look at a real-world scenario where tools like Aftermath would be beneficial. So you have an employee who works in your organization is really gunning for a promotion. And so they head over to Pirate Bay to download a cool, cracked version of Final Cut Pro to give their presentation that extra bit of razzle-dazzle. So once downloaded, they now have what appears to be a working copy of Final Cut Pro. But it also looks like they've installed a malicious crypto miner. Jamf Protect has coverage for this known threat. But what if there was another threat that was similar and we had an analytic for it that detects this behavior? Using Jamf Protect's analytic remediation, we can change a smart group in Jamf Pro, which will trigger a policy that will kick off an Aftermath collection and then sends the Aftermath archive to either AWS S3, Azure Files, or to Google Cloud Storage. So as I said earlier, one of the things I do here at Jamf is I maintain a repo for Jamf Protect. In this repo, we have custom analytics, unified log filters, API scripts, SOAR playbooks. And this is where you can find, if it clicks, I'm clicking it, clicking, there you go, finally went. So this is where you can find the SOAR playbook for Aftermath. Currently, like I said, we support AWS S3, Azure Files, or Google Cloud Storage. If you have any other destinations that you have at your organization, please file a feature request, and we'll be able to add those to the workflow. So requirements. First things first, we need somewhere to send the data to. So set up S3 bucket, Azure Files, Google Cloud Storage, whatever's supported by your organization. Check the README on the repo. There are notes about permissions. You just want put permissions. You don't want to have read or write or anything like that. As well as some additional requirements. You're going to set up like temporary credentials, at least for S3 and for Google Cloud Storage. And you're going to want to follow the directions just to how to set that up. Next, you'll want Aftermath. That's why we're all here. You can deploy Aftermath as part of your standard deployment. Or you can just throw it and have it installed at the time of the detection. So it's up to you as whether you want the app on your devices at all times. So we're all familiar with extension attributes. In Jamf Pro, there's the templates to import Jamf applications, and so you have your Jamf Protect extension attributes. We also have a bunch on our Jamf Protect repo, which gives admins more insight into the status of Protect across their fleet. For this workflow, you're going to want to install the Jamf Protect Smart Groups EA, and this allows us to do that smart group calculation at the time that the detection occurs. So for this talk, we're going to go over just an S3 example. So this is what it's going to kind of look like. So the analytic is triggered on Protect, which then triggers that alert, or triggers a Jamf Pro recon, which adds that device to the appropriate smart group. This triggers one of the three policies. So it's going to trigger the scan. And earlier I spoke about how if you wanted to add aftermath first, you could then put that before the scan if you wanted to. Once the scan finishes, it calls another custom trigger that starts the collection script, which installs, for this example, the AWS CLI, and then triggers another custom policy that will install the temporary credentials. So these temporary credentials are going to get installed via a package, dropped on the machine, and then once they're on, it'll send it back to the collection script to finish up, and then it will send it to S3. And like I said, the temporary credentials are only needed for AWS and for Google Cloud Storage. If you look through the README and the different examples, you'll see what's needed for Azure. Oops. All right, so in Jamf Protect, every analytic gives you the ability to add an identifier to the device that gets written at the time of the detection. By checking this checkbox, we ensure that the smart group is going to be populated in Pro. And then when we go to Pro, as long as we have a smart group created, and we're going to call it Jamf Protect Aftermath, just make sure that it has the same exact identifier you put in Protect. So we'll have Aftermath and Aftermath. And then the other thing to note, always use a like operator when you're doing your smart group calculation. Otherwise, this won't kick off. Once you have the script from the GitHub repo, you're going to throw this up into Jamf Pro. And I just wanted to make some notes about the variables and what they are. So the analytic EA, that's the identifier you've added. So at the end of the script, it deletes that file from the computer so that this workflow doesn't repeat. So make sure you always put the correct EA there. The AWS binary is just the location of that binary. By default, it's in user local bin, but if you install it with, say, like Homebrew or something like that, it might be somewhere else. S3 bucket and region, self-explanatory. This is where you want to put your data. The archive directory, that is where Aftermath is going to install that archive by default. As Stuart said, it's temp, but with the -O flag, you can put it wherever you want. AWS profile. So for this, and if you want to speak with me afterwards, I can explain this. So the credentials that get dropped on the machine, when you first create it, if you're familiar with the AWS binary, you have to configure a profile, and that profile gets a name, and that's the profile you're going to put here. So if you created like AWS configure and you gave it Aftermath as a profile, you would put Aftermath here. And then finally, the AWS folder is where those credentials are going to be stored temporarily. We're dropping them in opt and then .aws, and then we're also setting the permissions so that are only owned by root. But again, after everything is run, those get removed from the machine. All right, so in Pro, you're going to have three policies. The first one, as I said earlier, is the Aftermath scan. Whenever you set up a policy that you want to be triggered from Protect, you have to make sure that the trigger is Protect. So if for that first policy you run, make sure that has the trigger of Protect. When that finishes, it's going to also then do the AM collect trigger, which is going to kick off the collection script. And then during the time the script runs, there's another trigger that's going to be called that calls the policy to drop the credentials on the machine. Then everything gets uploaded to the S3 and then gets wiped. So now that we have this archive in S3, let's grab it on our admin system and take a look at the storyline. And I think that is you. Oh,
Did I skip it?
no, I did. You're good.
Okay.
One more.
There we go. All right, so we have this information now. We ran Aftermath on the endpoint. We have this information in S3. Maybe a security analyst brings it down to their VM, and now we want to analyze the data and look at that storyline. So how might that help us in an investigation? Well, this is the storyline from this Final Cut version for this person trying to get a promotion. So we look at the data. You can see it's pretty hectic if you just kind of scan through it and do a brief overview, but you can start to pick out things. For example, we can see that they navigated to Pirate Bay there at the bottom. This is chronological. Most recent at the top, going down. We can see that there are some transmission files, the transmission app, as well in app support. And we can scroll up as well and see that what actually happened was a bunch of files getting dropped on the system. So this ended up being the I2PD anonymous network layer, and was the goal of this malware, was to get this on the endpoint. So we can see that there's this big uptick in file creations in the user's app support directory, and we can kind of walk backwards from there. So this crypto miner would classify as a high severity, high fidelity alert within Protect. And as you can see, this would be the perfect application for deploying Aftermath and getting this type of information to see then what you need to be doing on the endpoint after the fact for remediation as well.
So a natural question that one might ask is like, what detections should we be applying this Aftermath scan to? And as we've said, it's open source, so it doesn't require Jamf Protect to use this. You would just need some way to trigger an action based on something happening. But if we're taking it from the angle of Jamf Protect, there's a couple of things to think about. So obviously the idea is that you can automate it. We don't have to do that. We'll talk about some of the ways that would be not automated. One of the counterintuitive things that you might run this on are situations where known malware was actually blocked. So it kind of creates a philosophical question of like, if Jamf Protect or some software blocks malware on a machine, is that machine safe, or like, does it need to be further investigated? Something we see a lot, for example, like in a crypto miner situation like this, we'll see Jamf Protect block a thing, and then the next day, that same endpoint, we get an alert that Jamf Protect blocked the same thing, and so on, and so on, and so on. And what happens in those situations a lot is the thing that dropped the executable that's getting intercepted is still on the device, and it's still attempting to do its thing. And so while, eventually, theoretically, something could get through or whatever. But the idea is, with something like Aftermath, you could have this holistic view of everything that's happened on the system to point you to those other artifacts that you can then remove and ensure that the system is clean. In terms of behavioral analytics, though, a good place to start is going to be the high severity detections, as Stuart mentioned. So you can go to the analytics page, you can sort by severity. The ones with the red dots are going to be high severity. By definition, these are not detections that you should be seeing on a regular basis, and they're the ones that are going to be the most concerning. So what I would recommend doing is doing this, going through. It's a good opportunity to go through and look at the detections that are there. In the last year or so, we've revamped all the descriptions if you haven't looked at them recently. And ask yourself, if I saw this alert, would I want a full system scan to help me untangle it? If the answer is yes, then that's a good candidate for running Aftermath based on. But you may not need to do it for every one. You might want to have multiple runs or policies of Aftermath where some are more lightweight, some are more heavy duty. There's lots of flexibility in terms of how you're calling Aftermath, of how lightweight it is. You might also have an organization, as I alluded to earlier, where, I don't know, maybe some organizations, even though it's a work computer, they're not comfortable with the fact that security can go and capture your browser history or something. I mean, it depends. Every organization thinks about these things differently. So I don't need to remind anyone here, But any policy that you can run can be performed on demand by making it available within self-service. So you can operate a policy as a service where you have a system scan button. Maybe you see the alert, you contact the user, you tell them to push the button to do the system scan. There's a little consent notice that pops up so they know what they're getting into by doing this. That's one way to do it. And maybe you train them to the point where, hey, something weird happened on my computer. I didn't necessarily trigger a protect alert, but I'm going to perform a system scan and I'm going to talk to IT about it. Just think about all of the things that become possible when you now have all of this timely and high fidelity data to work with. So that's the last thing about when. Let's kick it off to Alan to wrap it up with the things that we've added in the last year since we launched Aftermath.
So Aftermath V2, I think we actually merged it during the keynote. So
Cool.
it's nice and fresh. So as Stuart discussed earlier, we grabbed the browser history, downloads, and extensions from Safari, Chrome, and Firefox. 2.0, we're also grabbing that list of user notifications that users approve or deny. And those are little pop-ups that pop up, saying like, hey, do you want to visit this site? Do you want to allow this site to notify you? So we grab those. We're also grabbing additional browsers such as Arc and Microsoft Edge. In macOS 13, if you're familiar with ESLogger, this is a binary that's used to log events from the ES API. And so version 2.0 allows you the ability to kick off an ESLogger at the beginning of the collection stage. And by default, we're grabbing create, exec, and mmap events, but by adding an additional flag, you're able to then set which events you actually want to do. As well, if you don't want to, you can disable this flag as well. As well, Stuart went over this, but we are now doing grabbing that XProtect behavioral detections by collecting that SQLite database and var protected XProtect XPDB. Also, for unified logs, you can have a text file that has predicates that you want to add. And then if you add the flag, it'll do the unified logs plus whatever's in that, that text file. We're grabbing extended attributes of files. We are kicking off a TCP dump at the beginning of the collection process, so you get a PCAP file, and just general overall performance improvements. This is not what it looks like. This was the PR when I made these slides, so that image is out of date. Version 2.0 is on GitHub. I don't know if we have installer packages yet. Are we doing that? Do you know?
Not quite.
Not
will.
quite.
We'll
We
have
will.
those
So right now it's
in a
just the
week.
source code, but we will have packages, installer, uninstaller, and just the binary. And yeah, that's it.
Thank you. I don't know how we're doing time management here. Yeah.
We've got a couple of questions from the Q&A. I don't know if anybody in here was able to, if you weren't able to put up a question and you've got one, we can ask, but I'll give you what's in the app so far. So are there plans to include something like Aftermath natively in the Jamf Pro / Jamf Protect product, or do you foresee this always being an open source project?
It's a tough question to answer. I would say hopes to. There are hopes to. It's not on any like imminent roadmap at the moment, but yeah, definitely someday that's something we would love to have. It's just not anything that's coming soon.
Cool. And then we've got another one. We have customers that have a security requirement that does not allow the AWS binary to be installed on their machine. Are there options natively to Aftermath that allow uploads to S3 without the AWS binary?
So I know there is, but it's not in production by Amazon, and that's why we didn't include it. So once that Swift binary is not in development, we'll add that probably. So then you'll be able to just use the Aftermath binary to do the upload. And I haven't checked the status of it, but I think it's still in development.
It's still in development, yeah.
Yeah.
Cool.
I'll find some of the people from Amazon today and see if we can find out.
Cool. We've got another question that just popped into the question section. In the keynote, you mentioned about the Jamf AI. They mentioned that the Jamf AI that is able to ingest the alert and telemetry data in Jamf Protect and display to the admin analyst the AI's hypothesis. Has there ever been any thought looping Aftermath with that AI analysis?
I thought about it. I worked on both, so yeah, I mean, that would be amazing. I don't know how that would work straight away, but yeah, it's definitely something that has crossed my mind, yeah.
Cool. Was there anybody that couldn't put a question into the chat that had one? Okay, so I see 3. We'll start. I'm going to repeat the question, so if you want to ask it, yeah.
I was wondering with the different high priority alerts,
Yeah.
would you use the same identifier for all of them, or would you have to do separate ones?
You can use the same.
You could use the same one, assuming you had a monolithic run of Aftermath that was going to be the same, then yeah, you would just say Aftermath and add that as a smart group identifier for each of those. Or if you had multi, a lightweight one, then you would just designate that way. But yeah, you don't have to have a separate name for each detection.
Matt, I'll just get you to repeat the question for the people on the
Oh
live
yeah,
stream.
sorry. So the question is, if you're applying this to be automated based on a smart group identifier in Jamf Protect, unfortunately, it does require you to go into each analytic and add an identifier in the case where you want it. However, you can use the same identifier. Assuming that you're going to run Aftermath the same every time you run it, you can use the same identifier for every analytic you apply it to.
Cool. We had a question at the back.
Question for Stuart. Jeff, guys, might want to cover your ears for a second. Have you done any automated workflows with any other EDRs besides Jamf?
Just repeat the question real quick.
Have I done any other automated workflows with other EDRs other than Jamf Protect? I have not. I don't know of other ones that are currently in the process other than one of them, but that's the extent of my knowledge on it, yeah.
Cool. And we had a question over there.
Is Amazon AWS a requirement, or is there a facility to integrate with other S3 compatible buckets, such as Wasabi, for example?
We'd have to look at it. It's not a hard requirement. It was just the 3 most popular.
Low-hanging fruit, yeah.
Yeah. So.
Yeah, and anywhere you can put it, you could make a workflow to do it. We started with the ones that we thought would be, the most abundant in our customer base. But yeah, I mean, all the way down to you could literally call up the user and say, hey, can you email me, put that in a zip file and email it to me, or put it on Dropbox or whatever. I mean, just a matter of how do you get it. And the ideal user experience, if I was a security person, would be I see an alert, I pivot over to another window, and I already have that artifact package available to me without having to do anything in between.
And if you look at the scripts, they're almost similar. It just swap out
be easy to
out AWS CLI with whatever.
You got it.
And then you should be able to do it. Yep.
We've got a couple more questions that have popped into the app. So, given network security constraints, is forwarding to an internal S3 possible? If not, is it possible to forward to a discrete web server?
Sure.
Yeah.
Yeah.
Don't know why not, yeah.
And then we've got another one. How large are the dumps? Could we just upload them to Jamf
Huge dumps.
The hugest.
as an attachment via
No.
API rather than require external storage buckets to collect data?
I can talk to this though.
But yeah.
Yeah, they can be small, but it depends on what feature set you want Aftermath to run with. Like, you can collect the actual a copy of actual files in directories if you choose. But like, if you download the Xcode beta, there's 13 gigs in your downloads, and all of a sudden that file is enormous. So it kind of depends. Usually, I don't know. I don't want to specify because it depends on also how big the system is. Like, if it's a system that's been on for 3 years, the user uses it every day, they have a ton of apps and everything that make a lot of noise, then you're going to see that storyline or the timeline, right, is going to be way bigger than if it's a fresh system. So anywhere
Yeah,
from
and that's
small
kind of what I was
to
getting
large.
at with like the lightweight mode versus,
Yeah.
it's like, maybe there are some detections where you genuinely would want, like, I don't care, just give me their entire downloads directory, but probably not every time you see a reverse shell or something like that.
And also, the question was to upload into Jamf Pro's database, which
Oh
we
yeah,
shouldn't
no,
do.
don't.
Yeah.
Don't do that. So,
And I'd also be interested if someone has an idea of like the ideal light version, let me know.
Yeah.
That'd be great.
Cool. Is there any other questions before we?
Okay. Thanks.
Oh, there's one
Oh, I
question.
missed it.
So the new function, the adding unified log to the aftermath, so that part will be added to the timeline file in the alive.
Oh yeah, this is a good question. Is
Just
that-
repeat the question. So
The question is, I'll repeat the question, I don't know the answer. So we talk about doing the unified log capture where we go backward in time, and the question is, will those events that are returned from the unified log be collated into like the storyline? Yeah.
They're not right now. That's a great
Maybe in the
idea,
future,
though.
Yeah, we'll look into it.
if you want to, you can file a feature request, and then we can.
Yeah,
get
we'll
to
put
look
it
at
on the map officially then if you do that, yeah.
I have one more question. So do you have plan to make a script to dump the aftermath to other like integrate other scene product, or are there any other plans in the future with so far?
No current plans. Is that something you think would tip the scales? Okay, yeah.
Repeat.
So yeah, you're talking about a script that would install, oh yeah, sorry, run that by me one more time.
So instead you dump it into the third-party storage, then you dump it into the, for example, the scene product.
Yeah.
Something.
Oh, so so now it's gone to my S3, and then now that data is also going to be forwarded to a SIM where it can be searched on and all those things. No, we haven't, but that actually is it's something I think it has come up before.
Yeah,
We just
it's a good
haven't
idea.
gotten to it yet.
Yeah.
Yeah, that is a great idea.
Speaking specifically about ES Lover, if I'm dealing with an exploit that's able to suppress the messages that come back out of the ES API, is Aftermath going to show me the activity of a launch agent simply being suppressed? Or because the agent doesn't actually receive that message, is it going to show up at all?
Ooh, that's a paradoxical question.
Repeat.
yeah, repeat the question.
So the question is, if you had a malware that was able to suppress ES Logger, which I have never seen anything that's able to do that. If you were able to suppress the information in the Endpoint Security API, would the API be able?
Specify that use case.
Okay, please.
It's not that the ES API is being suppressed. There's a technique for evading
Okay.
around task logging.
Yes.
By basically put the launch user agents to sleep.
Okay.
If I do that, what happens is the endpoint security API sends out a broadcast, but the thing that's supposed to receive it in the user space doesn't.
Got it.
So then, if my exploit, my malware is doing that,
Yeah.
it's a technique similar to that.
Yes.
What it sounded like is Aftermath might tell me that if my exploit is using some other binary,
Yeah.
Big Bash or whatever, right? Like Aftermath might tell me that.
Yes, you would see. So yeah, the question is, yeah, if it had a way of essentially suppressing the agent in user space that's receiving the messages from the kernel, the ES API, yeah, in theory, you would see the launch agent or whatever the mechanism is that's doing that. You would see evidence of that completely independent of anything that ES would be showing. And the ES thing is. It's not perfect the way we're implementing it, but I think it is valuable because essentially we're running it while we're doing all the aftermath stuff. So you're going to see even the aftermath activity in there. So there's got to be some ability to tune that out. But that's something that we're exploring deeper of like what else could we do with the ES API with this type of
And in this case, I believe ES Logger's parent is Aftermath, like as far as processes go, because Aftermath is spawning it. So I don't know if that comes into play at all as far as
I think you
process.
guys thought it worked that way, that's why I wanted to ask.
Got it.
Okay. Thank you.
Cool. Thanks,
Thank you.
everybody.